A practical Wheatstone bridge is looking like this. Inside this box, the device is a Wheatstone bridge. And then the Wheatstone bridge was invented by Samuel Hunter Christie in 1833 and improved and popularized by Sir Charles Wheatstone in 1843 after 10 years. Inside this device, a resistor box, a galvanometer and some connections are shown. You can set the resistor value by using the knobs, whatever value you would like to for R1, R2 and R3. Left bottom corner the galvanometer it is. On the left top corner the connection for galvanometers. On the right bottom corner the 4 resistors are shown once again. On the right top corner the battery connection are shown. It is the instruction manual was written in this manual how to adjust the galvanometer to 0 resistance measurements, and then if this known resistor to multiply by how much, and then if this is unknown to multiply by which number. So it just all was in the instruction manual. And then it says like to use external galvanometer, to use an external battery, to use a rheostat. So all this instruction was here. And then to remove the battery, to replace the galvanometer, all was there. Let's have a look its operations. This is the circuit diagram of a Wheatstone bridge. So the Wheatstone bridge, in this Wheatstone bridge, 4 resistors. From there, one resistor is unknown resistor. Basically the main reason for Wheatstone bridge to measure very precise value of a unknown resistor. This is the main goal of the Wheatstone bridge. So R1, R2, R3, these 3 resistors value are known and this Rx value is unknown. So that's the point of issue. That's this Rx, we're gonna measure the Rx. So in between resistor R1 and R2, in the junction, this junction is like this node is D, and then in between R3 and then Rx, the another junction or node, this is node B. In between two, the galvanometer is placed. And the battery connection is on node A and node C. This is the battery connection. So how this Wheatstone bridge works? This works with this resistor R2 is variable. You can adjust this resistor. When you put one unknown resistor in between B and C, you can adjust this variable resistor R2 until these 2 points are balanced. That means you can adjust the resistor until you see there is 0 reading. When you see the reading is 0 in between these 2 points, that means there is no current passing from that side to that side or that side to this side. And at this situation it is balanced. So when you make balance for a Wheatstone bridge, and then the ratio for R1 and R2 is equal to the ratio of R3 and Rx, which is just like this. So the ratio R2 Rx R2 by R1 is equal to the ratio of Rx by R3. So from here we can easily find the value of Rx, which is R2 R1 times R3. So from this equation, using the Wheatstone bridge, we can easily find the value of Rx, which is unknown resistance. So we can do actually two ways. One is adjusting the variable resistor R2. Another is, if you don't have the variable resistor, or there is no options for R2 as variable. So you know three value R1, R2 and R3. Using Kirchhoff's law and voltage divider and current law, we can get easily the value of Rx, which I'm gonna discuss as well. So this equation is for when Wheatstone bridge is imbalanced. When this is in balanced condition, what will be happens if this is in unbalanced condition, and then you don't have the option for variable resistor R2? How you gonna measure this Rx? So let's talk about that parts now. In unbalanced, and then you don't have option for R2 variable. Now say this is in unbalanced. It is in unbalanced situation, and then you need to find Rx. So in that case, so we just try to find the voltage at point D, and then voltage at point B. So this voltage will be Vg from the galvanometer. So we are actually finding the Vg, the voltage Vg. So the voltage Vg, this is R1 and R2. If you use the voltage divider rule, then say this is Vs. So if you use voltage divider rule, so the VR2 voltage in here, VR2 voltage in here, it will be R2 divided by R1 plus R2 times Vs, using the voltage divider law. According to the voltage divider law, the VR2 is here, R2 divided by R1 plus R2. And then the same will be for the voltage here, Rxv, voltage R. So for Vrx, the voltage in here, the Vrx will be this will be Rx divided by R3 plus Rx times Vs. So say this is equation 2 and this is 3. So if we make a difference, the voltage between VR2 and Vrx, and then we can find the voltage difference for these 2 points, and which will be Vg. So the V voltage difference between B and D, Vg is equal to, according to me, according to my way, like it will be like V R2 minus V Rx. So we put this two equations value in here, and then we just come out the final equation, which will be like this. From this equation we have the value for R1, R2 and R3. Then we know Vs, and then if we know the Vg, and then we can easily find the value for Rx. After a long calculation, we just found that our Rx value is R2 Vs minus R1 plus R2 times Vg divided by R1 R2 Vg plus R1 Vs times R3. So in conclusion, the Wheatstone bridge calculation for unknown resistance is like this. Look, when the galvanometer is reading difference is 0, that means it's balanced condition, and then in that condition the unknown value for Rx will be find from this equation. For the balanced condition, and if the Wheatstone bridge in unbalanced condition, that means you don't have any option for variable resistor, but you know the resistance value for R1, R2 and R3, and then you want to depend on the reading for galvanometer or voltmeter, and then you find the reading and then get the value for Vg. Then after that you can get the value for Rx in unbalanced condition from this equation, which is this one. For unbalanced condition, you're gonna know the value for Vg, R1, R2 and R3, so Rx will be found from this equation. That's it. I think you enjoyed this video. Thanks for watching. Please subscribe. See you next time.